Today we'll be discussing section 2.4, which involves complex numbers. Alright, so earlier in the year we discussed how we can't take a square root of a negative number. So this is why we invented I. So I equals the square root of -1. Over here we have some examples of real numbers. +2, 3/4, the square root of 5, -0.37, they're all real numbers. The only difference is for imaginary numbers, if you guys look over here. So over here we have examples of imaginary numbers. We have the square root of 2i, 7i, and the square root of -16. You guys may notice that for imaginary it has to be an I, and then we'll talk about the square root of 16 in a moment. So over here I label my real numbers A and my imaginary numbers BI. So a complex number is going to be your real number A plus your complex number, which is your imaginary number BI. So we want to think of the imaginary dimension and the real dimension as a plane. That means we can plot these points. No, the imaginary dimension is not replacing the y-axis, but we're just trying to give it some space so that we can imagine these things. So if I wanted to plot 1 plus I, what I'm going to do is I'm going to go 1 in the real direction and then go plus I in the imaginary dimension. So here is my point. This is 1 plus I. If I wanted to go and do -1 minus I, that means I'm going to go -1 this direction, then I'm going down this direction, so my point will be over here as -1 minus I. So now we're going to be looking for patterns. If you guys notice, we have -1 and +1 for our real dimension. We have -I and +I for our imaginary dimension. Let's go ahead and start. We know that I equals the square root of -1. So for I squared, we know that I squared is I times I. And we know that I is the square. And we know that I is the square root of -1. So we have the square root of -1 times the square root of -1. So the square root of -1 times the square root of -1 is going to be the square root of -1 squared, right here. So we know if something is being squared and is a square root, the square root and the squares cancel each other out. So the square root of -1 squared means that we're left with -1. If you guys are visual learners, if you look at the graph, for the first one, for I, we're starting over here and going up to I. The second one, we're doing another round, and so we have I times I, which gives us -1. It lands on -1. Alright, so we know that I cubed is going to be I squared times I. We just found out that I squared equals -1, and we're multiplied by I. -1 times I gives us -I. If we look on the grid, we know if we go another round, we're hitting -I. So for the last one, we have I to the fourth. We know that's going to be I squared times I squared. And we know that I squared equals, so we know that I squared equals -1. So then we have I squared times I squared, which means we have -1 times -1, which gives us +1. So if we look at our graph, we know if we go another cycle, we're hitting +1. So as you guys may notice, we have I to the first, I to the second, I to the cubed, I to the fourth. Whenever we get to I to the fourth, we're making a full circle. So if I had to continue, this will be I to the fifth, I to the sixth, I to the seventh, I to the 8th, and it goes just in a circle. So now what we can do, and now knowing the patterns, is find I to a higher degree. So in the first example, we have I to the 10th power. What that really means is that how many times do we go around? So we start with, over here we have I to the 1st, 2nd, 3rd, 4th, right? This is I to the 5th, I to the 6th, I to the 7th, I to the 8th. So we know it's I to the 8th. If we keep going, we know this is I to the 9th, and this is I to the 10th. So we know that I to the 10th equals -1 because I to the 8th makes 2 full circles, and then I squared equals -1. Another way to think about this is just ask yourself, how many times does 4 go into 16? So we're on example 2. We have I to the 16. We're like, hey, what's 16 divided by 4? Hey, that's 4. So we have I to the 4th. Just looking at our table, if we went around, that means I have I to the 1st, I to the 2nd, I cubed, I to the 4th. That gives me 1. Looking at I to the 27th, ask yourself, how many times does 4 go into 27? You guys may realize it goes in 6 times. 6 times 4 is 24. So we have I to the 24th. What's left over? To get a 27, we're like, hey, that's I cubed. What we want to focus on is I cubed. We know from our notes that I cubed equals -1 equals -I. Or if you guys want to use a visual, we know that I cubed gives us -I. So what I want you guys to do is do I to the 41st power by yourself. We'll check it in class. Now we'll be adding and subtracting complex numbers. They work the same way. We're just going to be combining like terms. Pretend that I was an X. This is pretty much the exact same thing. Take a look at number 1. It says to add 3 minus I and 2 plus 3I. So here I just rewrote it. Make sure that you guys have parentheses. It's just a good habit to get into. And all we're doing now is combining like terms. So we have 3 right here plus 2. 3 plus 2 gives me 5. Then I have -I plus 3I, which gives me a total of positive 2I. So this guy right here, 5 plus 2I, is our answer. The next example says to subtract -7 plus 9I from 3 minus 4I. That means we're first going to write down 3 minus 4I and subtract -7 plus 9I. Since we are subtracting, make sure you have your negative sign. Make sure you guys have the parentheses. It's just like combining like terms, parentheses matters. So over here I have, look at what I have. Make sure you guys have wrote it down correctly. Make sure you guys distribute the negative sign. So when you distribute the negative sign, we have positive 7, and then we have -9I. All we're doing now is combining like terms. So I have positive 3 plus 7. You see how it doesn't have an I, it's just whole numbers, just real numbers. So 3 plus 7 gives us 10. And then we have -4I minus 9I. That gives us -13I. And that is your answer. So what I want you guys to do is go ahead and try out these 2 problems right here. Uno, dos.